add hematoxylin to stain these blue so that we can see exactly where the brown staining is and what part of the tissue has been stained. So it just provides a background so we can compare the brown staining to something. So the objective of this project was to optimize the conditions for the anti-PCNA antibody using these procedures. So what's PCNA? PCNA stands for proliferating cell nuclear antigen, and it's one of the central molecules that's responsible for apoptosis or cell death. And if it's in very low quantities in a cell or it doesn't work, then apoptosis occurs. So we were testing anti-PCNA, and we know that it's going to bind to the PCNA found in proliferating cell nuclei. And we have negative control, which is purified mouse IgG, and that's a blood serum that we use, and it should be the same species as the antibody that we're using. So we did mouse, so it has to be from mouse. So the methods. So first we wanted to compare different tissues, human versus mouse. So we took mouse testes in a human small cell lung cancer, and then we used standard fixation and antigen retrieval methods that were stated, were used in the lab as standard procedures. So we used, for fixation, we used the paraformaldehyde, and for antigen retrieval, we used the citric buffer, which had a pH of 6. And the results for different species, these are the negative controls. You can see that there's no nuclei that are stained brown. All this brown staining is background staining from color that it was trapped between the cells. So the actual nuclei are blue. Same in the mouse testes, so we know that that's going to be our control. And we're looking for brown nuclei. So we see that in the mouse testes there are brown nuclei that were stained in the antigen retrieval process, but there were no nuclei in the human tumor, and it's just more background staining and noise. So we know that the anti-PCNA only worked in the mouse tissue. So once we know that it works in the mouse tissue, we're going to test different fixation methods, paraformaldehyde versus PAX gene, and we're going to keep the same standard lab antigen retrieval method of citric buffer. And this was the mouse liver we used, and you can see all the nuclei are not stained brown. There's just more background staining. And with the paraformaldehyde, a liver, we know that it takes a very long time to grow, so there's not going to be a lot of proliferating cells, so we weren't looking for too many nuclei that were stained brown, but we saw a couple, so we counted that as it worked. And same thing with the PAX gene, you see a few are stained, so they both were successful. So anti-PCNA works in mouse tissue with both different fixatives. And the third condition, we were comparing retrieval methods. So we know it works in mouse testes, that's tissue, mouse, we know. And the fixation, paraformaldehyde, is standard, so we're going to use it because we know it works well in both. And then for the antigen retrieval, we're testing now citric buffer versus tris buffer with the pH of 9. So negative control, we see that no nuclei are stained brown. And when you use citric buffer, you see there's brown staining around the edges here. And same thing with the tris EDTA buffer. So we can conclude that it worked well with both retrieval conditions. So the summary is the anti-PCNA antibody, we tested in mouse and human tissue. It didn't work in human tissue. So in the mouse tissue, we tested in paraformaldehyde PAX gene, and it worked equally well in both. And since paraformaldehyde was a standard lab procedure, we decided to stick with that and test citric buffer and tris EDTA buffers, and it worked equally well in both of those. So we know that anti-PCNA will work in mouse tissue. And it will work in mouse tissue regardless of fixation or retrieval methods. So these are my references, and I'd like to acknowledge everybody at the Molecular Cytology Core Facility at Memorial Sloan Kettering, Dr. Fat, Harlem Children's Society, and Staten Island have recommended this program. So thank you. Any questions?
Hi. So my question is, you mentioned, you were talking about apoptosis, you were talking about tumors. So I have a general question about the intended applications of this research and how they might apply to.
Okay. Well, since we know that anti-PCNA is the PCNA is a proliferating cell nuclear antigen, so it's going to be found in cells that are proliferating. So we can, I guess, safely assume that there are going to be higher levels of PCNA in cancer cell or tumors because we know that they're highly proliferating. And if we can test for these, we can see that, where tumors are. We can see where we see greater growth of cells. So I guess that would be the application.
Well, I kind of have a follow-up question. So, if you can apply it in one direction, is it possible that you can apply it in another direction and use this knowledge to discourage them in the case of tumor?
That would be interesting further research to test. I'm not sure about that, but that'd be a good idea.